Is if you don't have linear programming as an option in Excel, or if you don't have Excel. So I'm going to show you how to work around not having that by using an online tool. Now this one has a lot of advertisements. It's not great. I had a really good one that I used, but it's no longer available. So it took me a little bit to find this one, but I've got it. So we're going to use a simplex method calculator. And this isn't a perfect solution. There's something I'm going to tell you to watch out for, but this will give us a pretty good idea of what we're looking for. So I will have a direct link to this. I'm just trying to clear it out so we don't have artifacts from the work I did, so we can build this solution from scratch together. It's going to give you the calculator with some example entries in here, and it gives you two choices. You can either do it up here, you can either build it up here with code, or down here using this kind of builder. I'm not going to use this builder. I'm going to show you how to do it with the code, because that's what's easier for me. This is kind of confusing. So it kind of pre-fills out what it's telling you should do, and you can see you're maximizing a variable. Call it Z. I'm going to call mine Z. You can call it whatever you want. You could even call it profit if you wanted to, but we're going to call it Z for this. And you can see it's using just math, algebra. You're going to maximize a objective function. Here's your objective function that we're going to build together. And then it's subject to these constraints. This is where you list all your constraints. So I'm going to keep in, like, see, the Kate Spade ad. That's great. Close that. Sorry about the ads. Skip the ad. Okay, so let's build this objective function out. And you can make these variables whatever you want. You don't have to use X or Y or X2 or X3. We're going to use A and B, because in our example, we're talking about toy A and toy B. So we're going to do, we're trying to maximize the profit. So you make $2 off of every toy A that you sell, and then you make $3 of every toy B that you sell. And we're subject to the following constraints. I'll get rid of the formulas now. So we have an inventory constraint that is $8 for every toy A plus $14 for every toy B, and that needs to be less than or equal to $20,000. And then for our total built, we're just going to do A plus B needs to be less than or equal to 2,000, because we don't want to build more than 2,000 in a month. So that's simply A plus B. And what linear programming does is it's going to rifle through a bunch of combinations for number built for A and B, and it's going to calculate all of this and figure out how to maximize your profit. If you wanted to minimize profit, you put min Z here. If you wanted to add constraints, you're free to add as many as you want here. I'm sure there is a limit, but I have not hit it yet. I've played around with it a bit. Also, we want to have A must be greater than or equal to 0, and B must be greater than or equal to 0. So what's frustrating about this is you'll find this find button. You hit the find button, and then to generate ad revenue, it makes you click through a couple times. It shows you how it's calculating it. This is really math heavy. Not concerned with that at all, but you're definitely free to look at that if you want. Yeah, see, you got to click all these ads. And then let's see if we have our solution yet. There we go. All right. You'll notice that you can't force an integer. I haven't figured out how to do that on this calculator, so unfortunately you're going to have to round down for both of these, and I'll accept that answer. So imperfect solution, but it works.